Hey guys, today we're going to do Unit 4, Lesson 2, and this is about dilations. If you remember back from Unit 1, we did discuss our rigid motions. So we had reflections, which flip, a translation, which kind of slides, and a rotation, which goes around. Today we're going to talk about dilations, which take a figure and make it either bigger or smaller than the original. So if you go to the eye doctor, you already are familiar with the word dilate. That is what they put drops in your eyes to do with your pupil so that they can get a better look at what's back there. So when they dilate your eyes at the eye doctor, it makes your pupils really, really huge, okay? And then they can dilate back down once that medicine wears off. So a dilation makes something larger or smaller, okay? And so all of the notes I've already typed here for you. There's nothing to fill in. Let's just go over everything one at a time. So we've discussed dilation. Scale factor is a ratio between the image and the pre-image. So I want you to remember that the image is what you get after. The pre-image is what you begin with. Okay? So in this little picture example over here, it's a little hard to see, but there should be little dashes there. Okay? This is the image because it's got those little tallies. This is the pre-image. This was the original. Okay? So we went from our pre-image, which was a larger triangle, to our image, which was a smaller triangle. All right? Okay. Let's just discuss the function notation really quickly. The capital D is for dilation. K, this is your scale factor. Scale factor. It is the amount that your figure will get bigger or get smaller, okay, compared to the original. And what you will do is you'll take that scale factor and multiply it by both the X and Y values in the ordered pair. And that's what I've done here. So there are some rules about scale factor. Scale factor can never be less than 0. It can't be negative because we are talking about making something bigger or smaller, not reversing it to the other side. Okay, that would be like we would need to do a shift or a flip or something else to move it a different way like that. So scale factor, if the number is greater than 1, it's going to make the image larger. It'll be an enlargement. If it is less than 1, so between 0 and 1, it will reduce the size of the figure and make it smaller. And if it's equal to 1, anything times 1 is just itself, so it's going to be equal to the original pre-image. So let's jump right in with our examples here. Okay, move some things out of my way and zoom in. So we have a triangle here, and they want us to find the image after it has been adjusted by a scale factor of 2. So this number is larger than 1, so this is going to be an enlargement. And let's go ahead and just plot these points really quickly. R is at -5 and +1. Okay, S is at -3, up 4, RS, and then T is at +2, -1. So this is what our original triangle looks like. I'm going to try to connect these points. so that we can actually see the triangle. So we are going to take each of these ordered pairs and we're going to have to multiply all the values in all the ordered pairs by the scale factor of 2. So I'm going to kind of show my work in a like this, okay? I need to multiply everything by 2. So there we have it, okay? Now I'm going to actually do that multiplication and fill it in down here, okay? So my scale factor is 2, so that's why I multiplied everything by 2. All right, so R prime is, remember, that's how I say that with the tally. -5 times 2 is -10. 1 times 2 is 2. S prime, -3 times 2, and 4 times 2. And then T prime, 2 times 2 is 4. -1 times 2 is -2. So these are the ordered pairs. Let's go ahead and plot these points so that we can visually see that this is twice as large, okay? So this will be -10 up to, this is my R prime, -6, +8, is right here. This is my S prime. And then my T prime will be over 4 down 2. Okay? And then I can connect these points. I didn't do a great job drawing a straight line, but that's what it ends up looking like. Okay? So you can see that it is larger. Now the center, the origin is the center of the dilation. Okay, so notice that they went equal distance away from the origin. Okay, alrighty. So that's important to note because we will have an extension where the point of dilation will not be the origin. Okay. All right, let's look at example 2. This is the exact same process. So let's go ahead and plot my points. W is at -4 up 8. X is at 10, 0. And Y is at -2, -8. All right. Now we're ready to apply the scale factor. The scale factor here is 1/4. So you can think about multiplying each of these numbers by 1/4, or that's the same thing as dividing them all by 4. So I need to divide everything by 4. Okay. Oh, I meant to do that in red. That's okay. And so now that everything is divided by 4, let's go ahead and simplify these. So this will be -1. This will be 2. 10/4, that's the same as 2.5. 0 divided by 4 is 0. -2/4, that is -1/2 or 0.5. And then -8 divided by 4 is -2. So let's go ahead and plot these points. I forgot to connect the points of my original figure. So let's go ahead and do our image now. -1, 2. This is W prime. 2.5 over 1 over 2 and about halfway more. It's kind of an estimation when you're plotting decimals, okay? And that is X prime. And then finally, my Y prime is -0.5 down 2. And so if I were to connect these, you can see that my triangle looks exactly the same, except it is smaller. In both of these situations, we ended up with a triangle that was either larger or smaller. And so I did forget to point out that this is a reduction in the second example. This is a reduction, okay? The triangles did not change in shape, only in size, and that is what a dilation does. So let's look at this bottom example. The vertices of this triangle are right here, okay? 3 vertices. Which coordinate pairs are vertices of, and then let's look at, okay, remember this is our function notation, a dilation of 5 onto triangle JKL. Select all that apply. So I'd like for you to pause this video and do a dilation of 5. A dilation of 5 on all of these. All right, guys, so welcome back. I pointed out here, out to the side, okay, that my scale factor, K, the scale factor is 5. So again, what that means that I need to do is to multiply all the parts of all the ordered pairs by the number 5. So -3 times 5, -2 times 5, 1 times 5, 4 times 5, 4 times 5, 2 times 5. Now, which of these were answers listed over here? So I see that I have A is a solution and C, okay? So 2 of them were correct and 1 was not correct. All right, great job, great job. Let's go on over to the other side of our paper and let's take a look at, I'm just going to leave this here for a sec. Let's take a look at how, if we're already given the image and the pre-image, how do we determine the scale factor? Okay, so I do want you to remember that the scale factor is a ratio where you have the image divided by the pre-image. So here's what I'm going to do for this. I'm going to write that down so that I remember. Image over the pre-image. So now what I need to do is choose a point. Choose a point. So I'm going to choose, I guess, the X value. Okay, so my X value is the image is 3, 3. And the pre-image, whoops, I just wrote this backwards. 3, 3, and the image is over 1 up 1, 1, 1. So you could really do this as 1 over 3, 1 over 3. So the scale factor in this case is 1/3. 1/3. That is going to be option A. Option C says 1/2. 1/2. Okay. So we had to do the image over the pre-image. Remember, the image is what comes first. The pre-image is what comes first. Okay, I've lost track of what number we're on. Graph the image of the quadrilateral below using the scale factor. So let's go ahead and figure out first. I don't know what my ordered pairs are. I need to figure those out, okay? So Q is at -1 up 4. R is over 1 up 2. S is +2, -2. So I'm having to look at where these points are plotted. T is at 0 because it's on the origin, and down 2. Now we need to apply the scale factor to everything. Well, the scale factor in this case is 3 over 2. 3 over 2 is the same as 1.5, okay? So whichever way you prefer to think about it, and you can use a calculator to help you. So we're going to multiply this by 1.5. Both of the points, the x value and the y value in each ordered pair. Okay, now I'm ready to write my image values. Okay, so -1 times 1.5 is -1.5. 4 times 1.5 is 6. So let's plot that ordered pair. -1.5 and down 6. 1, 2, 3, 4, 5, 6 is right here. Whoops, I went the wrong way. Sorry, guys. 1, 2, 3, 4, 5, 6 is right here. Okay, there's Q. Let's do R. I get 1.5 and 3. So 1.5 and 3. For S, I get 3, -3. Again, all I'm doing is using my calculator to multiply these. So my origin, 1, 2, 3, 1, 2, 3. And then my T is going to be 0, -3. So 0, -3. There it is. So here's my new points, or my new quadrilateral. All right, and it's just slightly bigger than the original. All right, let's identify the scale factor for a figure again. This time we don't have multiple choice. So I want you to just remember to choose a point. Choose a point. It doesn't matter what point. I'm going to use D and D prime. Okay, so remember, the image is the D prime. The pre-image is the D. Okay, so I have 0, 2. And then I have 0, 6. Okay. Well, I can't use the zeros because 0 divided by 0 is undefined, but at least I can use the 2 over 6, okay? 2 over 6 reduces to 1/3. So my scale factor is 1/3. So remember, I've got the image over the pre-image. That is my scale factor. Let's do it again, but this time we don't have an image. We've just got some points that they're giving us. So a translation of triangle IPO with these ordered pairs, IPO, after a dilation is, and then they give me the after points for the dilation, and I have to figure out the scale factor. So what I say is just, again, pick a point. Pick a point. It does not matter which point you choose, okay? And then we are going to do the image. And if it helps you to remember, the image is the one that has the little tally over the pre-image. So let's just go with O. O prime over O. And so my O prime is 10, 7. My O is 40 over 28. So either set of these numbers that you choose to look at, 10 over 40 or 7 over 28, they both reduce to 1 over 4. So my scale factor is 1 over 4. So you just need to remember how to set up your ratio. All right. Now, there is one more example in your notes. It is an extension example. I'm going to create a separate video that will talk us and walk us through how to do a problem like this. This is an extension where the origin is not going to be the center of dilation. All right, so be sure that you watch the extension video. And then after that, you'll go ahead and complete your assignment on Canvas. And if anybody has any questions, just either put it in the chat box or send me an email. All right, guys, until next time.